Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the limitations of octet rule. Before doing that, let us recapitulate the octet rule. Octet rule states that every element tries to attain nearest stable noble gas configuration by attaining 8 electrons in its outermost shell. That 8 electrons can be achieved by transference of electron, that is by the loss of electron or by the gain of electron, or it can also be achieved by sharing of electrons. So now let's start the limitations of octet rule. The very first limitation to octet rule is that of hydrogen, which we have done already. Let me write this thing for you. The very first limitation. The very first limitation is hydrogen. What's the atomic number of hydrogen? It's 1. What will be its configuration? Just 1 electron in its first shell. The nearest noble gas configuration. The nearest noble gas to hydrogen is helium, having atomic number to be 2. So the electronic configuration of helium comes out to be just 2. The 2 electron in its first shell. Now we know that the first shell has only 2 electrons. So in case of helium, that 2 electrons have been achieved. So helium is a noble gas. That means hydrogen just needs 1 more electron. 1 more electron to achieve the stable nearest noble gas configuration of helium. So that means hydrogen will try to attain, I'm writing, hydrogen will try to attain only 2 electrons. Only 2 electrons in its outermost shell rather than 8 electrons. So for hydrogen, the rule will be called as duplet rule. So hydrogen will follow duplet rule. Duplet means 2. The hydrogen will follow duplet rule but not the octet rule. Now let's talk about the second exception or the second limitation of the octet rule. The second limitation is incomplete octets of group number 18 elements. Incomplete octet of, group number 13. Incomplete octet of group number 13 elements. So now let's talk about the group number 13. The members of group 13 are boron, aluminium, gallium, indium, thallium. Now let's take an example of a covalent compound of this group. I'm taking it to be BH3. I'm taking an example to be BH3. Now let's make the Lewis structure of BH3. Firstly, boron. What's the atomic number of boron? It's 5. The configuration will be 2, 3. That means boron is going to have 3 electrons in its valence shell. So I have made 3 electrons. Now we are having hydrogen. We know that hydrogen has 1 electron in its valence shell. Now hydrogen will form covalent bond with boron to complete its duplet, that is to have 2 electrons in its valence shell. So the first hydrogen got completed as duplet. Here comes the second hydrogen that completed its duplet by forming a covalent bond with electron of boron. Now the third hydrogen will also form the covalent bond with the electron of boron to complete its duplet. So now let's count the valence electron of boron after the formation of 3 covalent bonds. That's the first electron for boron, the second, the third, the fourth, the fifth and the sixth. That means boron just got only 6 electrons in its valence shell after the formation of 3 covalent bonds. So here the octet of boron is not completed. So that's the limitation of octet rule in case of the covalent compounds of group 13. Now, let's take one more example. I'm now talking about AlCl3. The example is AlCl3. Now, what's the atomic number of aluminium? Is 13. The configuration will be 2, 8, 3. So the aluminium will have 3 valence electron, first, second and the third. Now let's talk about the 3 chlorines. Chlorine, what's the atomic number of chlorine? Is 17. So the configuration will be 2, 8, 7. That means chlorine is going to have 7 electrons in its valence shell. 1, 2, 3, 4, 5, 6 and the 7. Another chlorine, it's 1, 2, 3, 4, 5, 6 and the 7. The third chlorine, 1, 2, 3, 4, 5, 6 and the 7. Now, chlorine just needs only 1 electron to attain the octet. So chlorine will form 1 covalent bond with aluminium. So that's the first covalent bond, and the electron of aluminium gets shared with the chlorine and chlorine gets its octet completed. Now same goes to the second chlorine. The second chlorine again form a covalent bond with aluminium, so the electron of aluminium gets shared with the chlorine and again the second chlorine also got its octet completed. Now let's talk about the third chlorine. Third chlorine will also form a covalent bond with the electron of aluminium, so the electron of aluminium gets shared with the third chlorine and the octet of third chlorine also got completed. Now let's count the number of valence electron for the aluminium after forming 3 covalent bonds with 3 chlorines. Let me count the valence electron for the aluminium. The number 1, number 2, number 3, number 4, number 5 and the number 6. Here again only 6 electrons got completed for the aluminium but not 8. So here also octet rule got failed. Now the third limitation of octet rule. I am talking about the third limitation. The third limitation stands for expanded octet. The third limitation is expanded octet from period number 3 onwards. Let me take an example of phosphorus from the period number 3 and the group number 15. I'm taking an example of phosphorus and I'm taking the covalent compound of phosphorus to be PCl5. and we are going to talk about the expanded octet. That means the central atom, that is phosphorus, will have more than 8 electrons in its valence shell after the formation of all the covalent bonds in a covalent compound. Let me draw it for you. I'm talking about the phosphorus. What's the atomic number of phosphorus? It's 15. So configuration will be 2, 8, 5. So phosphorus 1, 2, 3, 4 and the 5. Now it's PCl 5. So that means we have to draw the Lewis symbols of 5 chlorines. So I'm taking the first chlorine. That's chlorine. It's number first electron, the second, the third, the fourth, the fifth, the sixth and the seventh. Now this chlorine will form one covalent bond with phosphorus to have its octet completed. So chlorine got 8 electrons in its valence shell after sharing 1 electron with phosphorus. Now let's talk about the second chlorine. That's chlorine 1, 2, 3, 4, 5, 6 and the 7. Now the second chlorine will form one single covalent bond with phosphorus. So the second chlorine also got 8 electrons in its valence shell. So the octet of second chlorine also got completed. Now let's talk about the third chlorine. That's a chlorine 1, 2, 3, 4, 5, 6 and the 7. Now the third chlorine will also share its 1 electron with the electron of phosphorus. So the third chlorine also achieved 8 electrons in its valence shell after sharing of 1 electron. So the octet of third chlorine also got completed. The same way the fourth one is a chlorine 1, 2, 3, 4, 5, 6, 7. Now this chlorine will also form the one covalent bond with the phosphorus. So the 8 electrons of the fourth chlorine also got completed, and the same way I'm writing the fifth chlorine is chlorine 1, 2, 3, 4, 5, 6 and the 7. Now the fifth chlorine will also form the covalent bond with the phosphorus. So fifth chlorine also shared 1 electron with phosphorus. So the octet of fifth chlorine also got completed. But my focus is on phosphorus. We have to count the number of valence electrons of phosphorus after the formation of 5 covalent bonds with the 5 chlorine. Let me count that for you. Phosphorus, I'm talking about the phosphorus, the number first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron, eighth electron, the ninth electron and the 10th electron. That means phosphorus in this case is having 10 electrons in its valence shell by forming 5 covalent bonds with the 5 chlorine. So here the octet rule is broken. Phosphorus is having more than 8 electrons in its valence shell after the formation of 5 covalent bonds. So phosphorus is having 10 electrons in its valence shell. That's more than 8 electrons. It's 10 electrons in its valence shell after the formation of 5 covalent bonds with 5 chlorines. Now let me take another example for this case. Now I'm talking about SF6. It's SF6, sulfur hexafluoride. Here we will focus on the number of valence electron of sulfur after the formation of all the covalent bonds. What's the atomic number of sulfur? It's 16. So the configuration will be 2, 8, 6. So I'm writing sulfur 1, 2, 3, 4, 5, 6. Now let's talk about fluorine. It's 9. Configuration will be 2, 7. So I'm firstly making 6 fluorines over here. Fluorine 1, 2, 3, 4, 5, 6 and the 7. Fluorine 1, 2, 3, 4, 5, 6 and the 7. Fluorine 1, 2, 3, 4, 5, 6 and the 7. Fluorine 1, 2, 3, 4, 5, 6 and the 7. Final fluorine 1, 2, 3, 4, 5, 6 and the 7, and one more fluorine. It's fluorine 1, 2, 3, 4, 5, 6 and the 7. Now fluorine is having 7 electrons in its valence shell. So the fluorine will form only one covalent bond with the 1 electron of sulfur to have its octet completed. That is to have 8 electrons in its valence shell. So I'm making the first bond. This is the first covalent bond, and after the formation of this bond, 1 electron of sulfur has been shared with fluorine. So fluorine got its octet completed. That is, it has achieved 8 electrons. The same way, second fluorine has also achieved 8 electrons after sharing a electron with the sulfur. The third fluorine also got its 8 electron completed after the formation of covalent bond. The fourth fluorine also got its octet completed after the formation of covalent bond. Then the turn of fifth fluorine, and then finally the sixth fluorine. Here all the 6 fluorine atoms have achieved 8 electrons in its valence shell after sharing 1 electron of sulfur with fluorine. So now let's talk about this sulfur. How many valence electrons are there in sulfur after the formation of 6 covalent bonds? And now I'm counting the number of electrons for sulfur. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Here sulfur is having 12 electrons in its valence shell after the formation of 6 covalent bonds with 6 fluorine atoms. So 12 electrons are obviously more than 8. So here also the octet rule is broken. So here we will talk about why there are the cases of expanded octet. The reason for expanded octet will be dealt in great discussion in the topics of hybridizations. And in case of the group 13 elements, the Bh3 and the Al3, how the boron will achieve the 8 electrons then, and how the aluminum will achieve the 8 electrons then. They will achieve the 8 electrons by forming the dimers. In reality, Bh3 exists in nature as a dimer, that means combination of 2 Bh3, that is B2H6. And AlCl3 also exists in dimers, that is Al2Cl6, which we will going to discuss in the topic of group number 13 elements in P block. When we will do the P block chapter, there we will greatly discuss about the group 13 elements, and there we will going to talk about their dimer nature. So that's all about limitations of octet rule. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.